Imagine standing at the base of the Great Pyramid or looking up at the soaring arches of a Roman aqueduct and asking yourself, how on earth did they build this without a calculator, without computers, without modern tools? It seems impossible. And yet, somehow, they did it. These ancient engineers turned stone, wood, and water into monuments that have lasted millennia. Long before digital technology, engineering was pure problem-solving. Ancient civilizations, from Mesopotamia to Rome, faced surging populations and the urgent need for infrastructure. With no algebra as we know it, no decimal system, and no instant computation, they relied on geometry, observation, and simple yet ingenious tools: ropes, rods, water levels, shadows, and even the stars. Knowledge wasn't stored in files. It lived in the minds of craftsmen, passed down through apprenticeships, honed by experience, and sometimes lost when civilizations fell. Take Egypt. Engineers used the cubit, a forearm-length unit, to measure vast distances. Knotted ropes helped create grids, while the stars guided alignment, letting them orient pyramids almost perfectly to the cardinal directions. In Mesopotamia, clay tablets recorded multiplication tables, early algebraic ideas, and practical tools for farmers and builders. Geometry became their secret weapon. A 3-4-5 triangle ensured perfect right angles long before Pythagoras gave it a name. Roman engineers took this knowledge and scaled it to unprecedented levels. They built roads stretching thousands of kilometers, bridges that still stand today, and aqueducts that carried water over valleys with a precise, gentle slope. Without GPS, lasers, or calculators, tools like the groma and chorobates allowed them to survey land and measure gradients. Arches distributed weight in ways that modern engineers still admire, and every failure was a lesson. Every success became a repeatable method. Fast forward to the Middle Ages, and engineering reached new heights, literally, with Gothic cathedrals. Master masons relied on compasses, straight edges, and proportional geometry to turn blueprints in their minds into soaring stone structures. Designs were drawn on plaster floors, apprentices learned trade secrets, and hundreds of craftsmen collaborated, fitting each arch and carving each detail without digital plans. Then came the Renaissance. Innovators like Filippo Brunelleschi solved the puzzle of the Florence Cathedral's massive dome, inventing double shells, herringbone brick patterns, and hoisting machines powered by oxen. Leonardo da Vinci meticulously studied birds and dissected human bodies to understand mechanics and movement. These engineers and artists weren't just building, they were experimenting, observing, and thinking like humans never had before. By the Industrial Revolution, the scale of engineering exploded. Canals, railways, and iron bridges demanded complex calculations, handled with tools like the slide rule, planimeter, and massive log tables. Projects like the Brooklyn Bridge required not just math, but ingenuity and extraordinary human coordination. Chief Engineer Washington Roebling directed construction from his apartment after being paralyzed by decompression sickness, with his wife Emily becoming the on-site expert, ensuring every decision was executed flawlessly. Across all these eras, one principle stands out: engineering is more than numbers. It is intuition, observation, collaboration, creativity, and the relentless drive to solve problems on the spot. Tools, from knotted ropes to slide rules, were extensions of the mind, helping humans visualize forces, materials, and geometric relationships in ways that computers today still struggle to replicate. So the next time you see a pyramid, aqueduct, cathedral, or bridge, Stop and ask yourself, who built this? It wasn't technology, it wasn't machinery. It was curiosity, persistence, and the sheer power of the human mind. Early engineers didn't just shape stone, they shaped the future. They remind us that the greatest tool of all is not digital, it's thinking. And sometimes that's enough to move mountains.